Clinker Factor, the cement industry podcast.
Welcome to the Clinker Factor, a podcast from WCA, which looks at the cement industry's response to climate change around the world and other topics of interest. I'm Ian Riley, CEO of WCA and your host on the Clinker Factor. Today I'm talking to Matthias Mersmann, the CTO of KHD, in the fourth and final one of our series, looking at technical improvements over the last 20 or 30 years and the impact that this has had on efficiency, energy efficiency, emissions, and particularly CO2 emissions. And today, rather than looking at the past, we're going to look forward to the future and what changes we might see. So Matthias, maybe I could kick this off talking about some of the improvements that we've already seen. And one of them that really sticks in my mind is the improvement that we've seen in the power consumption to produce clinker. So some of the most modern plants that are being built in China these days are showing clinker power consumption in the range of 42 or 44 kilowatt hours per ton. And then in addition to that, they're using waste heat power generation. So probably generating 30 or perhaps slightly better than 30 kilowatt hours per ton. So you've got a net 12 or 15 kilowatt hours per ton to produce clinker versus a global average, which is probably around 75 or 80. So perhaps this is an indication of what can be done with current technology even before we start looking forward.
Yes, Ian, that's right. And that's really impressive. And if you follow what has been the industrial reality for the last few decades, and you see what our cement engineer colleagues in China have been setting up and put into reality, that's really impressive. And it shows what is possible today already if the, say, environment around making these decisions is shaped appropriately. We know, of course, that in China, there are decisions and environments being set up for making decisions which are very strict and very stringent. And the Chinese cement producers, they adopt to it, and it shows what is possible. That is absolutely true. I guess in the Western world, the comparable electrical energy consumption is 4 or 5 times higher.
So if we look forward a little bit, we've seen some plants built in the last few years with 6-stage preheater systems. What other advances do you anticipate in the pyro systems of cement plants?
Well, first of all, the number of stages in a preheater should be corresponding to the amount of energy you need for drying the raw materials. So if you are in a dry region, you can go along with a 6-stage preheater and generate very low exhaust gas temperatures, while if you have wet material, you need more energy, so you will have a higher exhaust gas temperature. But apart from that, of course, in a cement plant, there are waste heat gas streams which can be utilized. And the Chinese example is showing that very nicely. I would see the sequence of developments, technological developments towards the decarbonization of cement production to run in waves along the timeline. And the first step will definitely be to increase the energy efficiency within the conventional technologies. And this will probably be the first step. Other steps with increasing technological change and depth of technological change will come later on.
And do you see different fuels playing a role here? So we talked in the last podcast about alternative fuels, but we also hear a lot these days about hydrogen and biogas and other zero carbon fuels. Is that something we should be expecting?
That's a very good question, Ian. Of course, in this situation as we're in right now, everybody is speculating, and I would say the box is open. The box is open for thinking out of the box, and naturally lots of ideas coming up now Hydrogen is certainly one of the most prominent representatives of alternative future fuels. However, we will experience that the generation of hydrogen is very expensive. And in terms of CO2, it only makes sense if this hydrogen is green hydrogen. So that means you need renewable energy in order to produce it. And that means that you would have to either have a lot of solar power or wind power or whatever is accessible for you in a specific case. And that is also referring to one specific we have to look out for. In the future, I am expecting cement plants to be much more diverse. With respect to the material they are using, with respect to the energy scenario they are utilizing, with respect to other logistical site conditions, which they're bound into. For example, a plant at the seashore with lots of wind power available would have easier play to generate green hydrogen. To utilize that in their energy scenario, whereas another plant wouldn't have that opportunity. They would have to go different ways.
Aside from hydrogen, the other thing that we've heard a lot about over, I guess, quite a few years now is the use of algae to create I suppose, a CO2 cycle. So the algae is grown with the CO2 that's captured from the exhaust from the kiln, and then is burnt as a fuel. Is that something that you would anticipate being viable in the near future?
Yeah, that's also one of those technological proposals that seem very far away. I can answer you that I did believe that almost 15 years ago, because then I started an R&D project myself on this attempt to close the cycle, to grow algae with the CO2 off gas, and then have a shortcut cycle, drying that algae with cooler waste heat gases, and then use these algae as a fuel. Sounds good, sounds elegant. However, what we are limited with in this, say, biochemical closed loop process is the growth speed of the algae. And it requires several magnitudes of growth speed increment. So I guess this is more or less related to genetic engineering, to provide enzymes that allow these algae to grow 1,000, 10,000, 100,000 times faster than they do today.
Yes, yeah. So that's very much the issue when we talk about using wood chips or bamboo as fuel. It's the same kind of issue as the quantity of space that you need for the in-process storage of the growing, wood or growing algae is a big issue.
Yeah, and let's not forget, it's not only, I mean, you mentioned the point, the amount of area you need to grow biomass. At some point, we will get into conflict with nutrition, with rightful nutrition demands to feed them people. So I think it's doubtful. Maybe there is, again, one individual case where it makes sense. But on the wider scale, I don't think that this will be a wider, more general technology.
Yeah, yeah. So, is there anything else that we should talk about on the pyro systems before we look at milling?
Well, definitely. There is a whole lot that is inside the box that is being discussed very intensely among the specialists. As I was alluding to earlier, I expect the first step to be consisting of energy efficiency improvements within the conventional technology, like waste heat recovery and all kinds of energy efficiency measures. Next thing, of course, is CO2 capture. Again, pilot plants have been set up already. We know this is a readily accessible technology. Consisting of something like a bolt-on end of the pipe technology to capture CO2. Again, there are different technologies available. We're going to see this happening. in very short time already. Then the next technological step would be to not only capture the CO2 behind a conventional kiln plant, but run this kiln plant in oxyfuel conditions, which requires an oxygen source, which can be electrolysis, which can be air separation through cryogenic or membrane or whatever. And then we're going to see that this technology is going to be developed and maybe implemented within late this decade. We see that the cement producers are requesting these kind of technologies already now because they have to set up pilots in this decade in order to get those decarbonization plans realized.
So the point of the oxyfuel combustion is that you produce a pure or fairly pure CO2 as the exhaust gas, and therefore you can capture the whole thing. Is that right?
Absolutely, absolutely. Carbon capture with amine scrubbing behind a regular kiln plant is very expensive. Mm-hmm. Because the concentration of the carbon dioxide in the off gas is not very high. So you have to spend a lot of money for this capture plant. And the logical consequence is if you can recirculate the off gas and just dose it with additional oxygen, just as much as you need to burn your fuel, you will be producing an off gas with something like 90 or 95 or 85, depending on specifics, percent of CO2. So that makes capturing much easier, or you might even find utilization ways to use this without additional concentration. That brings us to another important subject. What do we do with the CO2 once we've captured it? Again, this addresses a whole range of technological solutions.
Yes, and there's a lot of very interesting developments in that area, and which we've touched on, I think, in some of the previous podcasts. And I think, today, if we said, well, what is really proven technology, then using the amine stripping system for capturing the CO2 and then storage, I think is probably considered now to be proven technology, but is very expensive. I guess that leads to two problems. One is the investment required to realize that, and the other is the possibility that having spent that money, it may be that there are much lower cost ways of doing it in the future.
Yeah, maybe also undoubtedly, there will be the need for investment, and cost both in CapEx and OpEx will go up. I think it would be naive to believe we would get along with the same cost base like we have now. And maybe the costs necessary can only be borne if we come to a cross-sectoral cooperation between the cement production and other industrial processes in order to integrate their energy and their mass flow scenarios into each other to take synergetic effects on both sides. It is well possible that we will see a renaissance of what we know in Germany as a Kombinat, which has been a tradition in the former Federal German Republic to combine different types of industrial activities in order to get synergetic effects in the energy and mass flow sheets. The important message at this point is just, I think it's fair to say there are thousands of engineers over the world working on these issues with high pressure. And the most important understanding is that we'll have to come up with pilots this decade.
Absolutely. So just moving on to milling, we talked about the improvements in an earlier podcast. Are there other new opportunities to reduce that further on the horizon?
Yeah, if we talk about milling, and we may follow the same sequence like we did in pyro, we'll have to accept the fact first that milling is one of the most inefficient processes man ever operates on Earth. There is something like maybe 5 or 6% of the total energy which we put into a milling plant that is actually used for comminution, for particle surface generation. But it seems like we have no other choice. If we make the switch from ball mills to high pressure grinding technologies like VRM or roller press or other devices working on high pressure, we can almost double the efficiency. So that corresponds to lifting it from 3 to 6% or from 2 to 4%. Still, we're wasting a lot of energy, but there is no way around it. So we have to accept it at one time. Still, with respect to grinding technologies, we're going to see some innovation. Will be driven mainly by new requirements we put on the products. If we change the raw materials, if we change the cementitious supplementary materials we add into the mixture in order to create cements of new types, we will certainly generally reduce the hydraulic perfection of this mix by adding something different than clinker. If we reduce the clinker factor, then naturally we will arrive at a higher demand towards higher fineness of cements. And this will call for highly efficient, but also plants which are able to reach thresholds like, for example, 7,000 Blaine or maybe 8,000 Blaine in the future. And that is a range that is not really achievable by vertical roller mills and roller press plants. So the highly efficient grinding technologies will not by themselves easily reach this quality, this fineness. So we're going to see probably a combination of another high fineness grinding technology in combination with the highly efficient high pressure grinding technologies.
Mm. And the high fineness grinding, is that going to be ball mills again, or is that going to be something else?
Actually, today already there is a trend to reactivate the sometimes in some regions forgotten ball mill, to run it after roller presses or after vertical roller mills to achieve just that, to improve cement quality and arrive at higher fineness. However, if you take a ball mill, your energy deficit is immense, and I cannot believe that this should be the end of our technological development. It may take a while, but there are some other proposals around which need to surely mature in the utilization in a robust industry like cement is. But I guess there's going to be an alternative to the ball mill, I guess.
Okay. So that's a good move from milling to look at the products that the cement plants may be making in the future. So I think we've seen some of that potential, I guess, with the move from OPC to LC3 in a few markets. Is that something that you would anticipate becoming more widespread?
We will definitely see that. The lever here is clinker factor reduction. And naturally, if we pre-assume that the amount of concrete will more or less remain to be on the same level, which I believe, then we'll have to substitute this clinker with a different material. And that's gonna be probably also not only lime-based material, but also clay-based material, calcined clay, LC3, well-known subjects and well-known technologies. They are going to find their way into the cement world, I'm sure. The problem here is whatever composite cement you are going to create, in order to have it used by the building industry, it needs to fulfill the standards and norms of quality and safety. Nobody will build a highway bridge or a skyscraper with a type of material that is not passing the quality and standard criteria. So the problem here is that these procedures are judging on the durability on many years, and we don't have that much time to make an experiment and wait and see whether LC3 is good after 20 years. So there's a conflict built in this matter, but I'm sure the necessity to decarbonize is so strong that whatever is possible to reduce clinker factor will be done by the cement producers, I'm sure. And we're going to see a lot of different types of admixtures and composite cement types.
One of the possible trends, of course, is that we could see the use of higher strength concretes in smaller quantities. This is something that there have been some studies done on that have shown that by using higher strength concretes with better cement and typically, of course, higher clinker factor cements, you can actually reduce the overall amount of clinker that's required for the building. So I think what this does is it underlines the need for the whole supply chain to work more closely together. I think in designing buildings, the architects and engineers that are designing the buildings are not trying to optimize the CO2 in the construction materials. And this is an area that we've talked about for a long time, but it's actually very difficult to work on in a practical way. Is that something that it's a little bit outside the cement plant, but obviously it impacts what happens in the cement plant? Is it something that you think has mileage in it?
Yeah, it's a good point. And again, it addresses an intensification of cooperation between, industrial sectors, which might have been adjacent in the past and might to intensify their integration. And just as much as the cross-sectoral cooperation will increase, I guess, as things are getting tighter and tighter in their requirements and the requirements ever more stringent, everybody involved needs to find the potential within his reach. And it's not only the example you just mentioned. There are also lots of ways to reduce the overall carbon footprint in the concrete area and in the building industry, as you mentioned. Numerous proposals are being discussed and displayed. Curing concrete with CO2 has just won the prestigious prize as one of the most efficient technologies to reduce the overall footprint. So some people raise the question, what is going to be the dominating decarbonization technology in the future? I find it always hard to answer that, because the pressingness of the issue will, for my understanding, force us to use all of that.
Yes, I think that's absolutely right. I mean, there are lots of good ideas there, and I think it will be necessary to use many of them. And over time, of course, we'll figure out what the optimum is.
Mm-hmm. And there will be a development over the time. There will be some bridge technologies which help us on the first run, but they will be then exchanged by more efficient ones, which are not available today. So there will be a development.
Yeah, I think one of the other things that's interesting in terms of the impact of COVID is that it's accelerated the adoption of new technologies. Within the plants, we can see that BIM technology has become, I think, more popular as a result of companies needing to cooperate together and being limited in terms of their physical cooperation. So I think that as you see these Industry 4.0 and BIM technologies going forward, that the potential to facilitate the sort of cooperation that you're talking about is also being strengthened.
Absolutely. And the example with the video conferencing among people using, say, information technology, if you relate this to machines communicating to each other, you're exactly in what we call Industry 4.0 or Internet of Things. It's the same thing. It's about the intensification of communication, be it among people or be it among machines.
Yes, I think that paints quite an interesting picture of the future of the cement industry. We've had an industry that has been, pretty conservative and fairly homogenous in many ways across the world. And as you were mentioning earlier, it seems that the direction in which we're going, at least for the next several decades, is likely to create an industry that's much more diverse in terms of the technical solutions that are chosen to produce cement at a much lower carbon footprint.
Absolutely, absolutely. We have we can realize that for the last, say, 5 decades, the way to produce clinker was always the same. We're talking about a kiln plant consisting of a cooler, a rotary kiln, a preheater, and most of the plants a precalciner, and that's it. And if we look now, what we are looking at, not only talking about oxyfuel plants, but there are so many other things like carbonate looping, capture, waste heat recovery. All this produces a diversity in that basic flow sheet of cement clinker production, like we never had in the last 5 decades.
Yes, yes, absolutely.
It's a wide and deep field. All these potentials in automation, everything that comes with digitization will play an important role. We briefly touched IoT, or Industry 4.0, artificial intelligence, online optimizers, again, connectivity, intensified communication will also play an important role. But that's, again, something that is building on technology that is available today already, like waste heat recovery. We're going to see lots of artificial intelligence-driven online optimizers in the next few years already. That will also be an important step for our industry to take. And if you compare our industry to other industries, we have to admit that we are not the fastest one to adopt to these. There are numerous studies around which always show the cement industry in the later thirds of adaptivity to these. But this is because of the complexity of this process. We have to admit we're dealing with natural substances, we're dealing with huge size equipment, and it's not so easy to apply these technologies to our production process.
Yeah, so the picture that you paint is an exciting one, and I think one that hopefully will make the cement industry more attractive to talented engineers and scientists to work in the future.
I agree. If you're looking for a really challenging, interesting industrial engineering job, I can only recommend the cement industry.
Yes, well, with that, Matthias, perhaps we should wrap up today. It's been great fun doing these 4 podcasts together with you. I'd like to thank you very much for all of them.
Thank you very much, Ian. It was a pleasure for me.
And perhaps we can find an excuse to do some more in the future.
I'll be with you.
All right.